Ready to go? You know what? One of the things that I most liked in this conference is the background music between sessions. Now there's Rod Stewart, and you want my body, and you think I'm sexy, so yeah, so exciting. Well, there was this reminded me that last May in Stockholm, I was there for the DevSum conference, and the same days, Rod Stewart was in town giving a few concerts, and a few people actually didn't make, I've been told, that some people didn't make to the conference because of the Rod Stewart concert. So, well, I really wish that my talks could be as much sexy as his talks, his songs are, but you decide, you judge that. So let me try to make sexy a talk about domain-driven design. What does a software architect do? Nothing sexy probably, but essentially a software architect is called to design software for one particular reason, to make a customer happy or to have the customer pay. And to make this happen, software ideally should be design driven by something. Primarily, the requirements we get from users. And from the requirements we get from users, we try to understand. We should be trying to understand the internal mechanics, the characteristics of the business domain for which we are writing the software. The time we have, the money we've been told we'll get are other reasons that contribute to the actual design of the software we do. But the most important points are, of course, the first two. So the requirements we get from users and our understanding of those requirements, which leads us to prepare a list of functional and non-functional characteristics that the system has to have. Let's talk requirements then. Now, most user requirements we get, regardless of the methodology we use to acquire them, requirements come from different users. And the largest is the organization for which we are writing software, so the largest, the biggest is the organization of the customer. The more people we need to talk to. And everyone we talk to delivers us his own vision of the system. And sometimes it pretends his vision of the system is the universal vision of the system that everybody needs to have in the company. More likely instead, the vision we receive from each individual user is just the perception and perspective of the entire system he has from his own position, his own department, his own office, his own seat. So it's on us the burden of cleaning the amount of words we receive from users to try to extrapolate what is really relevant. Albert Einstein used to say, everything can be counted, but not everything you can count does matter. Sort of the same can be said from requirements. We get many of them, but not because we heard certain requirements. Those requirements really fit into a general purpose, functional organization of the system we are called to write. Sometimes, some other users, those who are or think they are more technical, they try to suggest what we should be doing. They tend to blink to suggest subliminally that, oh, it's just a database we need to use, or it's just a service, it's just a microservice, it's just this, it's just that. And in some way they instill the idea of the direction we should take with the design towards a certain technology. Okay, don't get it wrong. The customer has technical customers or technical person in a customer organization. They have all the right to say, we don't want to use this technology, or we have investment made in this other technology. We have internal policies that force us to do this but not that. This is absolutely legitimate and right. But what I was talking about is, especially in small companies, small customers, you sometimes talk to relatively technical people and they try to lead you towards the direction they think you should take, regardless of the effectiveness of the solution. This is critical because when this happens, there is a sort of trend that takes to minimize the effort required and the complexity of the system. It's just a bit of UI on top of a database. Okay. It depends on what is your definition of a small UI on top of a database. Because if you take this literally, it's a total piece of shit. It makes no sense. But if you raise the abstraction level, well, everything is an interface, a front end on top of a database or on top of stored data. Front end on top of stored data, everything, nearly everything. Every piece of software is like this. So it says all and nothing at the same time. But anyway, user requirements by definition are incomplete, inaccurate, and ambiguous by design. It's one of those things we cannot change. There is the sky, there is volcanoes, rivers, water in this planet, user requirements. Everything in this world has a number of characteristics. User requirements are incomplete, inaccurate, and ambiguous. What is a user requirement? Definition: the capability, it is a capability that the system must have in order to satisfy a business need. I think that everybody can absolutely agree to this definition. But when you talk to users, this is what you experience. I took this picture myself in front of the Trevi fountains in Rome. Crowd. Million people talking, taking pictures, throwing words and words and words at you. Just words. You are swamped, overwhelmed with words. And out of these words, you should take out requirements. And in the amount of words you receive, there are probably 4 different categories of words. Some words belong to the category of business suggestions, trying to tell you where we need to go with a successful system. Another category is functions. So some of those words try to tell you how we should get there, where the business aims to go. Some other words describe runtime conditions. So what we need to have to do to be along the way as we manage through functions to reach the objectives of the business. And then there is the 4th and worst category, features. The benefits of going there. I mean, I think that all of you last night attended the Q&A session. It was last when we talked about .NET Core. At some point, the question asked was, okay, what is the benefit money-wise for me, my organization, my customers of using .NET Core? And if you try to find yourself an answer to this question, opening Google and making research or attending conferences, you are swamped with words that belong to this category, showing the benefits. But benefits are beneficial if they effectively brings you to live in a more effective condition or to write software more effectively. So not because, just to talk to the .NET Core, you can run your application on Linux in general because the platform allows you to do that. It is beneficial to you. If you are and intended to be and to stay on IAS, the fact that there is a new platform that allows you potentially to run on Linux is not per se beneficial to you, but to other companies, to other person willing to, I don't know, save a bunch of money to drop Windows servers and use Linux servers while hosting their .NET-based code, that could be really beneficial. So it is a matter of deciding, judging with your own eyes and your own brains, and the features that users throw at you during interviews and meetings and discussions are things that they think you should have done in the software. But again, the feature is a human perception of the software. We are called to write applications that achieve a business goal in a way that is respectful of the processes in the company. So, business functions, conditions, and features are all words we have to turn into two categories of specifications: the well-known functional and non-functional specifications, where the functional specifications are indicated as steps to implement and cross-cutting concerns, so things we should be worried about around the system when we implement functions. Now, requirements essentially take to form an idea of the business domain and the logic and the rules and the processes in this business domain. Now, no matter what, there are no two identical business domains. Of course, if as an architect you served in a company that does usually banking software, you have a pretty good experience in issues, okay, that you can find when writing software for banks or for the logistics market or for insurance or for real-time monitoring, statistics, it depends, whatever. But still, every company, every organization is the same. I did some consulting work last year for one of the 3 companies in the world who do software for the logistics. So all the shipping being done in the world runs over, so I've been told, 3 software systems done by 3 different companies in the world, and I was doing this consulting gig for one of these 3. So this company sets up, has a system, a product that they adopt, configure to shipping companies, okay, that do exactly the same job. So company A, B, C, D, they do shipping. So all they are interested in is in tracking boxes, packages, containers, routes, ports, airports. So it's the same kind of thing, the same job, same domain, same business domain. Yet, they told me that nearly every shipping company calls things in a different way, in a slightly different way, and modifies certain business elements, configures certain business elements in a slightly different way. So even though the highest level processes and business domains and pieces of business logic are the same, yet there are differences in each customer, and they cannot, of course, nobody can really afford to have a custom version of the software per each configuration. So this is essentially one of the things we must be aware of. A business domain is usually larger than the system we are going to write. So there are essentially two possible scenarios here. You are writing a software that is a sort of a multi-tenant application, so that has to be configured on many potential customers and configurations. In this case, you must be as flexible as possible, and you must really understand a lot about the abstractions behind the business domain. Otherwise, the other scenario is you work for one company, which could even be your company. So you are not concerned about making the software general enough to be configured for many possible different scenarios, slightly different scenarios. But you have to, again, to focus on the tasks you need to perform. In this case, you figure out that the general business domain, banking, insurance, logistics, is far too wide than the system you have to build. So in this case, if you fall in this second scenario, there is really no need to build a super bigger perfect system. So, pragmatism, look at exactly what you're called to do, has a trivial and foregone as it may sound, is exactly what we should be managed to do. What does it mean? The risk is that we deliver software. If we miss figuring out which camp we belong, we essentially may end up delivering software that works, but not the way that customers like, which means we failed. Let me tell you briefly a personal story. I do some work for a company who is active in professional sports. We provide IT services for professional sports. To give an idea, there is a big sport event. There is a lot of TVs around that, media around that. There are information with live scoring, whatever, being displayed around the venue. That's fine. Most of the content you see there passes through services we provide, which are, in the end, ASP.NET MVC applications exposing JSON that Flash applications consume, period. Now, to keep all this thing going on, we needed at some point years ago, an internal system to have our people to configure tournaments, sports events, right? For example, tennis tournaments. We need to insert in our system to feed web services that then Flash applications will consume live. We need to enter the list of players. We need to enter the list of tournaments in the year, details about the tournament. So we have essentially a data entry system. We needed that. We hired a company. I was too busy at the time. And we told them what to do. So we played the role of the customer. And because we hired a company run by people with a very good reputation, we didn't, in a way, we said, okay, let's have this company build the system. We gave instructions, high-level instructions, and they built the system. The system they built worked. Nothing to say, except that it didn't work. So it worked, but not. It worked, but not the way that the customer, us, wanted. Let me concretely, one of the problems we still face years later, because we had no bandwidth to rebuild entirely it from scratch, is they used to indicate a draw in a tennis tournament, the term tournament instead of draw. So the entire system, database tables, APIs, everything in the system, the UI of the system, calls tournament what people in the business calls draw. And to indicate when they realized along the way that, oh my God, we call the tournament something that is not a tournament, because in the business tournament means something different. The different thing was called tournament group. So you see the point now? When in the company, in everyday processes, dumb people filling data into the system says, what is the idea of this tournament? Everyone else has to ask, what do you mean by tournament? Is it the tournament as we mean, or is it the tournament group as the system calls it? This created essentially a conflict, a clash that every day, many times a day, we face. And this is just the detail in this system that is easier to explain to everybody without getting into the details of how this, but there are plenty of other things, some of which we had to fix manually. And I took care of that. And it took me 6 months after the time it took to build the entire system from scratch. So my evaluation of this company was they did a good job, great job as developers, but they totally failed as architects because they failed understanding, in first place, the language of the business. And because we have a great reputation, we are MVPs, we deal with that, they didn't prove to be humble enough to sit down and learn from the domain experts the real mechanics of the system that they were called to build. Because we didn't ask them to plan from scratch a system that worked, allowing anybody to create tournament records, players, this or that. We asked, this is the world in which we live. These are the rules by which we play. We need a system that allows us to do only these 4 or 5 different things. So they designed a huge, immense general system instead of a much smaller segment of it. So sometimes the business domain is much larger than the real system you are called to build. And to help addressing this scenario, there is let's call a methodology that I call UX-driven design. I realize that I'm the only one in the world that apparently uses this expression. So if you Google UX-driven design, you fall into something I said, talked about, or written. UX-driven design is essentially a methodology in 3 steps. Build up user interface forms as users love them. This methodology works beautifully in situations in which you are simply called to give your customers software that works, that allows them to perform better a few business processes. So it may or may not work as effectively if you are building from scratch a system that has to support multiple configurations for potentially any possible customer you may have one day. So the first thing is give users screens they love to work with. And users can tell you that. Beyond words that try to explain the general mechanics of the system, the physics of the universe, we need to be able to enter this data, and we like to enter this data in a text box, using the mouse, using the finger, scrolling. They can tell you, even giving some UX suggestions. But that's the way we would love to enter things. This is the information that it could be helpful to see available at hand in the same screen. I got a call from an internal customer a couple of weeks ago saying, look, we have, there's in the form, in the home page that we use, we have tournaments identified by name because we thought it would have been enough. It would be helpful, immensely helpful instead, if we also can see right there the numeric ID of the tournament. That will simplify and streamline our own internal workflows. So this is the feedback that users should be able to give you as soon as possible. And that shows up in a much easier and fast way if you, as the first step of your design, focus on building user interfaces as users love them. And to do so, you don't use software generally. You use a new family of products called wireframing tools. PowerPoint or Visio, but especially PowerPoint, can be one of those tools. But other tools are Balsamiq, Axio, UXPin. There is if you Google wireframing tools, also free wireframing tools, you find probably 10, 20 available. And I do recommend, but even Balsamiq is the simplest but still one of the effective enough tools. And even if you want to buy a license, it's not free actually, Balsamiq. It costs you 100 euros per a lifetime. So 100 euros perpetual. It's a good deal. And that allows you to quickly create with the same speed or even more than the speed you use to create a PowerPoint slide, even faster than PowerPoint because you have a pre-arranged UI elements. You drag and drop, you save as PDF, you send the PDF to the customer, and because it's a PDF, the customer can get you back via email comments. So you don't even have to stick on a phone or organize meetings. The work can be done offline, and it's immensely helpful and speeds up things. Then, once you have, for every business process you have to take care of, you have all the screens approved by users, then you're mostly done. Can you believe it? What you have is a bunch of screens, but each screen contains the list of data that comes in and out of that form. So from that form, you push a button or trigger an action in some way, and some information is moved to the server. You can figure out the outline, the prototype of that information from the screen. If there's a text box, it's a string. If there is a data picker, it's a data, and so forth. So on the back-end side, what kind of data you are going to receive in each situation. So you have a list of endpoints with a clear, well-defined input that the UI is going to call. So create your application layer as a collection of classes exposing public methods with exactly the same prototype with the data that forms are going to call. And now you have an arrow connecting presentation to application layer. An arrow that, once the users have approved the interface, it's done. It's really, really close to deliver the experience that users would love to have. Something can still go wrong, but the chances it really goes wrong or significantly wrong, these chances are significantly diminished, really, really, really close to zero. And after that, once you have the entry point in the application layer, you have data that comes in. You also know what should be served back to the UI, what is the next screen. So you have an input, you have an output. And you have, from requirements, rules, business, algorithms to implement. But whatever you do in the implementation of workflows is essentially something that it's a black box with a well-known input and a well-known output. Whatever happens underneath, it's just business logic. It's key, of course, for the methodology to work effectively. There should be a sort of waterfall separation between the preliminaries of testing, iterating on until you reach satisfaction on the UI, and then development. We talked CQRS many times yesterday. It's nice to, if you reflect even more, so once you have a form that users love, from this form, from any of these forms, it's easy to see which buttons, which actions you can trigger represent something that alters the state of the system or something that reports back the current state of the system. So you see that UX-driven design quite naturally drives towards a CQRS, a command and query separation type of architecture. And usually at this point, an objection is, okay, but words, these are words. Where is the model? Where is the data model? Where is the database? I really believe that, maybe it's because of relational programming, maybe it's because of astral conjunctions, but the generation of software architects grew up with the obsession of data models. And the obsession of data models, in a way, established a link between objects and tables, and brought everybody, or nearly everybody, to mostly think in terms of data rather than in terms of behavior that manipulates data. This is what I tried to explain yesterday in the talk about domain modeling. We should ideally move towards a world in which we get and set properties to a world in which we pass data and ask for some action to be taken. In a way, this is the promise, the alluring promise, or the alluring requirement that domain-driven design over 10 years ago pushed to us. So domain-driven design is, however, was not completely received, in my opinion, well by the community, because for some reasons, and I can hardly explain why, but fact is that now domain-driven design is mostly perceived as having an object-oriented model where classes implement certain patterns internally. While I cannot deny that this is a possible way of looking at domain-driven design, I would say that domain-driven design is much more serious a thing than having an object-oriented model. And the pillars of domain-driven design are three things called ubiquitous language, bounded context, and context map. The nice thing about this is that the same author, the creator, the father of domain-driven design, Eric Evans, he wrote the Blue Book, where he presented domain-driven design to the world, I think back in 2003. And then, 5 or 6 years later, a QCon conference, London, 2009, he gave a presentation where he said, this is what I have learned about domain-driven design 5 years after the book. If you go on YouTube and type QCon 2009 London Eric Evans, you can still see the video of this presentation. And the core thing he says in that talk is, if I had to rewrite the book now, 5 years later, I would flip, I would swap the main two parts of the book. In the book, which was never republished and updated in this regard, the first things you read in the first half of chapters, there is the idea, it's to address, to tackle complexity in the software. You should aim to have a software model for the domain, and then to exemplify, it creates this software model as an object-oriented model. Then in the second half of the book, in a way, Eric attempts to give some theoretical justification for the practices he introduced in the first half. And then he talks about something he calls DDD, strategic design, and he introduces these things: ubiquitous language, bounded context, and context map. And in that talk, he says, if I had to rewrite the book now, I would swap these two types of content and first tell that DDD is all about this, is mostly about this, and then when it comes to implementing concretely those principles, you can build a software model that, for example, is made of an object-oriented model where classes implement a certain patterns, blah, 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 blah. Or not. Or you can do anything else you can call and qualify as a software representation, functional software representation for the model. So a piece of software that allows to achieve certain goals, period. Now, ubiquitous language. It's a shared vocabulary of terms. If you don't agree with your contacts on a project on what any given term means, that's a problem. If you don't know, when you say tournament, what do you mean exactly, what everybody understands by that word, you have a problem. This is the purpose of ubiquitous language. Because in any business meetings, there are domain experts, there are development persons, and each of these two groups of people have their own lingo, their own jargon. The ubiquitous language is essentially a common vocabulary of terms where most of it are words and verbs referring to key, fundamental business concepts, and a subset, a small subset, are still technical terms, because we are still writing software. And when we write software, we are still necessarily subject to what we call cross-cutting concerns. Security, caching. Those things are still logging, tracing. Those things are still necessary in any piece of software. And in some way, the fact that we cache, deal with security, log, and trace impact the structure, the tasks we perform in every visible piece of code. So it makes sense that some of these terms show up to be known, common, technical terms in the space of the problem we are solving. Another point is the ubiquitous language is made of nouns and verbs. But nouns and verbs are linked together. I guess you might have been familiar in some moment of your life especially I guess as students, with the concept of grammars in languages and in programming languages. A grammar is essentially a set of rules that describe how keywords relate together. The ubiquitous language is sort of that. So you have nouns, invoice, order, tournament, and you have verbs. So a tournament can be started, can start, finish, can have a draw created, can have an entry list of players, and so forth. So not every noun maps to every verb and vice versa. So wherever you have a noun which represents a domain entity, you also have a finite number of actions that can have that entity as the main actor. So, vocabulary of valid words, nouns and verbs, formal grammar for generating valid expressions. So, essentially, you have a noun, which methods, which action, what is the behavior we want to associate to this, to the entity represented by this noun. That's the point. Not all verbs can be used with all nouns. We can perhaps accept an invoice, but we cannot accept an order. Accept an invoice, that's another point. Now, accepting an invoice is a typical business expression. Have you ever sent an invoice to a customer? You weren't paid, and when you emailed back, say, look, do you have any news about this? Oh, I'm sorry, we forgot to register or to accept, it depends, your invoice. That's the lingo they use. It could be, depending on the company, it could be accepting an invoice or registering an invoice or whatever else. That's the way, that's the language they use. Even though in software, even in the world's simplest accounting system, in the end, accepting an invoice is creating an invoice record on some database. But in the business, it's accepting an invoice. So, invoice is a noun, accept is a verb that goes with that. Regardless of the technical actions, inserting, deleting, updating, we end up doing in the concrete implementation. An invoice, accept, binding. At the same time, if you have an order, which are in the business, the actions you perform, the users in their own business processes and workflows perform on an order. They can perhaps create an order. They can start processing an order. They can cancel an order. So when an order is canceled, for us, it could be, I don't know, a delete on a database record, or more likely, it could be a logical deletion, so marking a Boolean field on the record with a true value, meaning it is deleted now. But the notion of deleting an order is not a business notion. In the business, you cancel the order. Order, cancel. Order, create. So every noun has a list of business-friendly terms. And we must learn those terms. Not because we want to write more elegant code, cooler code, just to understand what we are called to do and to do it right the first time. So delete the booking typically becomes cancel the booking, submit the order. Yeah, okay, we submit an input form that represents the order, but actually it's checkout most of the time. Update the job order in an ERP system is likely to be called extending the job order. Create the invoice is typically register or accept the invoice. Set the state of the game, if you are in the gaming industry, could likely be something like starting or pausing the game. But the blue names, the blue expressions, are learned from user requirements, from the analysis we do from the amount of millions of words we receive from customers out of interviews and meetings. Now, how would you manage concretely the ubiquitous language? It's a list of files, so it can be an Excel file, can be a OneNote, can be a wiki, a shared Google Drive document, something that is easy to read and update perhaps under certain permission controls. But probably a wiki, if you can afford that, or perhaps an Excel file. It's just a dictionary of easy reference. It must be kept up to date, otherwise we failed. Because it's created, we need to have a dictionary in place when we start writing code. But as we complete sprints, we must go back and update that. If we learn new things, oh, we did this wrong. Oh, actually, no, the tournament is wrong name. It's better called in another way. Let's rename everything. If that means in development changing something in the processes, let's do that. If that means creating new classes, new components, new services, let's do that. So that the structure of the software reflects one-to-one the structure of the ubiquitous language. It's not a static thing. It doesn't even change indefinitely. At some point, we have to consider that frozen. And more importantly, the ubiquitous language must be reflected in code, used everywhere. It's the language of the project in user stories, requests for changes, meetings, emails, technical documentation, schedule, and source code. Especially source code. So, ubiquitous language is not simply a freaky new name for just naming conventions. Another one, second point of domain-driven design, bounded context. So we have a problem. The problem is building software for a business domain. So we are in the problem space and we identify a domain. And in the solution space, according to domain-driven design, we have for a domain a software model for the domain. In short, a domain model. But if in the domain, so in the problem space, we can identify areas of the domain that can we split on for reasons like it's easier to handle, it's easier to develop, but also there are differences in the ubiquitous language, for example. So let's split. So if we identify subdomains, logically analyzing the domain, in the solution space for each subdomain, we have something that domain-driven design calls a bounded context. If we have in our mind a huge model for the domain, the bounded context splits this into smaller pieces that typically don't overlap, but sometimes they have some overlapping, which is a problem that has to be addressed in a different. Raises another set of problems. But let's assume for simplicity that bounded contexts do not overlap. So we have split a system which was, in our initial analysis, a monolith into blocks that interact in some way. Not all of them are related to all of the others, which is good. Because if we go back here, and we have a piece of code that stands here, that has no relationship to a piece of code that stands up there, so this block is not related to the block over there. But the moment in which those two pieces of logic are coded in the same monolith, are you really sure that no hidden dependency set up or shows up at some point, some form of regression, connects together, creating invisible, subtle dependencies to pieces of code that are totally independent. More. Suppose that the actual logic you need to have here and there is better addressed by different programming languages or different approaches or different technologies. If you are in a monolith, you probably end up creating a solution that is a trade-off, which means that none of the two is optimized for the task. And that creates sort of dependencies, constraints in your overall architecture. So splitting, if there are reasons to split, allows you to treat every blue block here as an independent project, or in general as an independent piece of software, as an independent software model for a subdomain, for a bounded context. And the white arrows serve as the map that binds together elements in the context. So, bounded context and the context map, which says essentially how bounded contexts are related together. A bounded context has essentially three main characteristics. It has its own ubiquitous language. So two distinct bounded contexts have different ubiquitous languages. Maybe slightly different, but different. So if you realize that people from different, say, departments, or people involved in a different, significantly large functionality of the system use confused because one calls a thing in a way and the other one calls the same thing in another way, or they use the same term to mean different things, or the same logical thing has a different set of attributes, different properties, okay? I don't need to see the list of orders for a customer. I only need to see the customer that gives me 3 properties and that's it. So what is the right representation of a customer that keeps those 2 people satisfied? If the problem of keeping everybody happy becomes a problem for you and you are the only one not happy, you better split. You better find a way to create separate, distinct domains, and each domain has its own super optimized domain model. I know that as developers, we grew up with the idea that duplicating code is bad, is poor, is horrible. But that's the way to scalability. If we don't replicate and duplicate immutable, especially things, we don't scale. And here is not a matter of scaling for performance. It's scaling to achieve a way to better deal with growing complexity. It's an abstract form of scalability. Because a bounded context has its own ubiquitous language, it has its own software model. And because it is its own software model, you can use in that software model any implementation details, even technologies that you reckon right for the job. And right means also in light of the people and the skills of the people you have. Yesterday in the Q&A session, I said that you can still be doing a domain-driven design analysis and then end up having, in one of the bounded contexts, web forms and data sets. I mean, I was not trying to provoke anybody. It's true. Because the power of domain-driven design analysis is in recognizing the map of bounded context and finding the relationships between contexts and, as an architect, in assigning the priorities. So which of each pair of connected bounded contexts has the highest priority? which has an impact on how you schedule work, or how releases are organized. But the fact that we have distinct bounded context, it means that software-wise, there is no interrelation between the two blocks of code. And if some data exchange has to occur, that data exchange must be ruled by an explicit contract, whatever that means. It's a bridge between two islands. Every island has, if the islands are different countries, they can have different language, different dialects, different political rules. Still, you can have a bridge that allows people, according to agreed rules, to move from one island to the other island. That's a geographical metaphor to explain, or regions that many countries are organized in. Federal regions sometimes, right? And, okay, you use language, independent implementation, and wherever necessary, a contracted, well-known, explicit interface to connect to other contexts. When do I recognize the need of a bounded context? In practice, I have a couple of suggestions. One is when, and this typically happens in large systems, when you talk to customers and you figure out you are confused by some terms, that some people means different things from when they say a given word. So if this happens, stop there, reconsider what you have learned so far on the project, and because probably you are crossing the invisible boundary of two bounded contexts. So no matter what you have learned so far, if you face the fact that ambiguity in business words and business terms, stop there and reconsider, because probably there is room for splitting the domain in two parts. The other sign is essentially when you realize that keeping apart some services would make your development easier, or the final solution maybe faster to scale, deploy, or whatever. The concept of bounded context is really close, at least theoretically, to the context of, to definition of microservice. Honestly, I don't know what a microservice is actually. I'm going to attend the next talk from Sean Farmer to try to figure out what the fuck is concretely a microservice. But the idea I have of what it could be, well, it's pretty close. Different level of abstractions, but it's pretty close to what a bounded context is. Or probably a microservice could be one possible way to implement concretely what you recognize as a bounded context out of your domain-driven design analysis. Okay, and this slide just contains when the language changes, what does it mean, what it means. Another great example of bounded context is legacy code. So this slide summarizes, if you have a dependencies on an external system you don't control, you have to buy the services of, I don't know, Google Maps, then in the realm of your application, the wrapper around the Google Maps and Google Maps itself is a separate bounded context that some parts of your code depend on. Legacy systems, same story. That's create a wrapper and that's it. That is another bounded context. Or portions of code that, based on your experience, you better keep separated and distinct from the remaining monolith of your application. Now, as an example, we have here the schema of a typical e-commerce, simple e-commerce website, and the white blocks are functionalities you need to have. So you need a front end, you need some application logic for the shopping cart to prepare the commands pushed to the back end, which is made by the accounting, by the payment interface, and the payment gateway to PayPal or whatever it is. You have the shipping front end and the shipping gateway to whatever FedEx or whatever company you happen to use. You also need to have likely a back office, which is another front end. You need to have persistence. You have business rules in the middle, and business rules depend on some data in the persistence. So, we enable a campaign, and the details of the campaign are read from persistence. So, the white blocks are functions you need to implement. Now, the blue blocks attempt to give a possible organization in bounded contexts. And the words try to explain that even though the entire thing here is one ASP.NET, say, application, within the context of that we can recognize separate areas that are treated independently, which means that even different people, can be used so they can be allocated to separate groups of people. So the front end can be the bounded context number one, an ASP.NET MVC application which incorporates in the server process some application logic to deal with the shopping cart. Business rules, they can be perhaps a separate class library where we have maybe a domain model, maybe some anemic classes with some external components that contain the algorithms we want to use. Again, we can have a domain model or not. So we are doing a domain-driven design analysis, but I'm not saying you have necessarily to have a domain model with classes organized in a given way. The biz rules, depending on your deployment perspective, can even be a standalone web API or another standalone site. It depends on the scalability needs you have. But it could even be a class library just linked. The back office, well, can be just another front end, another area of the MVC application with a different set of controllers, or it can be a completely separated website. admin.mysite.com. And because it's a completely different web application, you could even use web forms there and data sets. The admin probably is simply that stupid data entry. If that's the case, and if you have people that is pretty damn fast at using web forms, why not? So the demo, the example, you can use web forms and still be doing DDD, finds now a concrete example. The persistence can be, again, a class library linked, referenced by all the other pieces, or it can be a separate standalone web service if you do persistence via HTTP. Accounting is typically, again, a class library or a standalone web API. Payment and shipping are reasonably class libraries, and that operate has the technical term is anti-corruption layer, so that it's a facade around the native API of the gateway, PayPal, FedEx, whatever it is. Now, given this, every blue block must be allocated. So as an architect, you are responsible for allocating the development of those things, making technology choices, and so forth. Relationships. There are a few relationships between two bounded contexts. One is conformist, which says that for every relationship, for every bounded context, so you draw an arrow, the two endpoints of the arrow indicate the downstream or the upstream context. So who is the master? The upstream is the master, the downstream is the slave. This said, in a conformist relationship, there is no room for negotiation between the master and the slave. The master rules, period. So as an architect, when you establish a conformist relationship between the two bounded contexts, you are saying the team in charge of the upstream context rules. So the other team must just be conformant to whatever release, schedule, feature, decision is made by the other team. You decide that as a lead architect. Customer supplier is the same thing, except that as the chief architect, you allow some negotiation. Okay, guys, the final word belongs to the upstream context and team, but you guys talk if there is some conflict or if some adjustments that keep you both happy can be made. A partner is when the relationship actually doesn't have a master and a slave, but both are master and slave at the same time. It's a 50-50 kind of thing. And it's called the partner, mutual dependencies between the two contexts. Shared kernel is when there is overlapping between bounded contexts and some code must be created and shared by both. The classic shared class library, and the team that is in charge of that is in partner with all other bounded contexts that use that. So it's a partner to the maximum power. Anti-corruption layer is when it's related to, it's not actually a relationship itself, but helps understanding. It's a layer of code that isolates dependencies from other parts you don't control. Typically, is on top of a conformist relationship. Essentially when you have a dependency on legacy code or dependency on external systems you don't control. Okay, thank you very much for your time. Coffee and relax. See you next year. Thank you.